I will give the final moderator, Mark, President of OGC, to somehow make a kind of summarize and conclude, including the first two sessions.
Well, thank you very much, and I thank all of you for hanging on, because there's still more to come, and appreciate you staying with us. Just a quick note, and I'll keep it within 2 minutes. You saw a lot about successes and activities in different regions. You're going to hear now from a few speakers talking about things from an international perspective, but I wanted to point back to Jimmy's talk for just a minute. I don't know if you noticed this, but not only was he using the standards, but they were in the OGC process influencing the standards with industry. So they found a problem, they went into our process, they worked with our members, and then they took the results and implemented them. That is an exceptional model that's happening over and over again in the OGC process. What I'd like to do now is introduce Fraser Taylor. He's going to give us an overview and talk about the GEOS experience. Now we're truly going international and probably interstellar. Fraser, you have the floor.
Thank you very much. I'd just like to echo the comments that there's some very, very exciting work going on in this region. And as I had the opportunity to see work all over the world, there are very few areas of the world which are doing more exciting work than this one. And I'm very impressed by both the presentations and by the other stuff. I'll be talking today about data sharing at the international level through the GEOS experience, and my presentation is on behalf of one of the GEOS working groups, the GEOS Data Sharing Task Force. My presentation outline a little bit of the background on GEO and GEOS, an introduction to the GEOS Data Sharing Task Team and the GEOS Data Sharing Task Force, an overview of the data sharing principles, the data sharing implementation guidelines, and the data sharing action plan. According to the GEOS 10-year implementation plan, here is the purpose of GEOS. It really deals with observation data from remote sensing imagery in space rather than land-based information. There are 86 countries, plus the European Commission, 61 participating organizations, including OGC, which is very active in GEOS in terms of the use of GEOS OGC standards and specifications for the purposes of GEOS. And Dr. Cho already mentioned that already there are linkages with existing OGC implementation processes in the GEOS process. The various committees on GEOS, architecture and data, capacity building, science and technology, user interface, monitoring and evaluation, and the one that I sit on, the data sharing task force. These are the 9 societal benefit areas of GEOS: disasters, health, energy, climate variability, water resource management, weather, ecosystems, agriculture, and biodiversity. The GEOS implementation plan indicates that societal benefits of Earth observations cannot be achieved without data sharing. That's a truism, but it's absolutely central. And it's not just a set of words. It's absolutely vital that people share information, and it sets out the GEOS data sharing principles. There are 3 of them. You can read them here as well as I can. Those are the principles that were established in 2005. In 2006, GEO established the task force to further the practical application of agreed GEOS data sharing principles. The task team is led by CODATA, an interdisciplinary committee of ICSO, and the task team produced data sharing principles white paper, which was a broad review of existing guidelines and data sharing barriers and was published. To reinforce the principles of data sharing within DIOS, the 2007 Cape Town Ministerial Summit recognized that the success of DIOS will depend on a commitment by all geo-partners to work together to ensure timely, global and open access to data and products. And further, they supported the establishment of a process with the objective to reach a consensus on the implementation of the data sharing principles for DIOS to be presented in 2010. The DIOS Data Sharing Task Force, to build on the initial work of the task team, was set up, and its objectives were implementation guidelines, because the principles were so broad that you could drive a bus through them, and what was needed was firm implementation guidelines, an action plan to implement the principles, and supporting documentation, including assessments on the actions to be taken, and some representative costs and benefits and responsibilities for the proposed data sharing processes. Here are the implementation guidelines accepted by the Geo-Ministerial Plenary in 2009. Full and open exchange of data. Users to be able to reuse and redisseminate shared data, metadata, and products. Consistency in the implementation of the DIOS data sharing plan with relevant international instruments and national policies and legislation. Just a little bit of word about this one here. DIOS works by political consensus. Each nation has its own policies and priorities. There is no way that we are able to persuade some nations to fully implement the data sharing principles, regardless of how much we would like to do that. Therefore, we have to recognize the political reality that there are going to be constraints, and there are going to be partial responses to data sharing principles. If we stuck our heels in and said, no, you must fit all criteria, we would lose. Therefore, we have to compromise in the process by which we arrive at data sharing and recognize that national policies and legislation are going to be important and will limit the amount of data sharing that will take place. We're asking for pricing policies which are consistent with DIOS, reducing time delays and promoting research and education uses. When endorsing the implementation guidelines, the Geo-6 plenary accepted that in the context of the DIOS data sharing task force, full and open exchange means that data and information made available through the DIOS are made accessible with minimum time delay and as few restrictions as possible on a non-discriminatory basis and a minimum cost of no more than the cost of reproduction and distribution. And notice we said data and information made available through DIOS. Countries have the opportunity to decide which data sets they are going to contribute. They've also got the opportunity to decide which data sets they're not going to contribute. Some nations will contribute large amounts of data, others will contribute not so much, but both are open. We welcome all data contributions when registering data into DIOS. If there are restrictions arising from relevant international instruments, national policies and legislations, then publish them. We'll still put the data into the DIOS data set so you know it's there, and if there are restrictions on the data, the restrictions are explicitly outlined. The Ministerial Declaration committed all DO members to maximize the number of documented data sets made available on the basis of full and open access and create the DIOS data collection of open resources for everyone, so-called GEOS Data Core, a distributed pool of documented data sets with full, open and unrestricted access at no more than the cost of reproduction and distribution. So the data core is a number of data sets that fit all of the requirements for full and open access at no cost. And we are also trying to develop flexible national and international policy frameworks to ensure the more open data environment is implemented, thus putting into practice actions for the implementation of the principles. So a little bit of education, trying to persuade nations who are not participating to move in that direction. Now the Geo Plenary and Ministerial in Beijing in 2010 accepted the GEOS Data Sharing Action Plan for implementation of the GEOS Data Sharing Principles. It builds on a crucial concept of full and open exchange and on the implementation guidelines accepted by the GEOS Plenary. It notes that the achievement of full and open exchange of and access to key data sets will require actions by GEO collectively, members and participating organizations individually, and GEOS tasks and cross-cutting activities. We recognize that GEOS is composed of voluntary contributed systems and data, which are governed by pre-existing laws, policies and practices that may not at this time be fully compatible with the concept of full and open exchange of data, metadata and products. We also acknowledge that GEO welcomes all data contributions into GEOS, including data with restrictions based on legitimate reasons, with data providers identifying these restrictions when registering data in GEOS. There are 8 actions to be pursued, some by GEO collectively, some by GEO members, and some by GEO members and others. Data Sharing Action 1. Create the GEOS data collection of open resources for everyone to address geo-societal benefit areas. The GEOS Data Core, a distributed pool of documented data sets contributed by the GEO community on the basis of full and open and unrestricted access at no more than the cost of reproduction and distribution. The data in the GEOS Data Core is a subset of all data registered in GEOS, but it's there as a core. Then they asked for the establishment of a task force within GEO to monitor and promote and evaluate. Because it's one thing putting principles and action plans in place and implementation plans in place, but they've got to be monitored and evaluated. We want to maintain the GEOS common infrastructure as the architectural framework essential to implementing the data sharing principles. And there is a document describing this. And we want to integrate the implementation of data sharing principles into the activities of all GEO committees, not just one. It's one of the cross-cutting requirements in GEOS. We want to establish national coordinating mechanisms to promote and monitor engagement with the implementation of GEOS data sharing and provide feedback to GEO, and develop flexible policy frameworks to ensure a more open data environment is implemented. We're trying to maximize the number of documented data sets made available on the basis of full and open access. The presumption is if you provide the data with no restrictions, or don't specify them, then it's fully and openly available with no restrictions on use. We're trying to promote the data providers the benefits of full and open access to data. In 2011, our principal focus has been on the implementation of the GEOS Data Core. We've done very important work on the issue of licenses, copyright, and other approaches that are compliant with the definition of the geostatic core. We're looking very carefully at some of the legal aspects involved. We want to implement the geostatic core in the GEOS common infrastructure. And we want to notify the GEO community about the launch of the geostatic core. We're reporting on this in 2 weeks at the plenary session in GEO in Turkey. That's where we are. 1 or 2 brief remarks, if I may, since I've finished in reasonable time. The problem with voluntary groups like GEOS is that they are voluntary. The advantage of groups like GEOS is that they are voluntary. It's like the argument or discussion we had earlier over legislated opposed to voluntary. In GEOS, there can be no sticks, it won't work. There have to be carrots. We have to persuade people that this is to their advantage. Because if we do not, we will not arrive at any legitimate solution. I would also point those of you who are interested in the whole concept of data sharing to all of the very carefully documented papers around this. There's an excellent paper just being completed this week on legal interoperability, which covers all aspects of the legal aspects of interoperability, which are rarely looked at collectively. And I recommend it to you. The Data Sharing Task Force is a group of 5 or 6 lawyers, led by Paul Hulier from the United States, who made an excellent collection of information relating to legal interoperability. This is already up on the GEO plenary website as one of the documents for the GEO plenary in Turkey, in Ankara next week. So it's a very valuable resource. The second document, which I think is particularly interesting and useful, is the one on liability. Again, it's a very carefully documented piece of work by some of the best legal minds in the world on the concept of liability, looking at geospatial data in particular. So those 2 documents are new and very important and powerful ones that you should look at. In addition, I think some of the background papers on data sharing are amongst the most comprehensive written that I am aware of on all of the aspects of data sharing, including things like privacy, confidentiality, and so on and so forth. Now, the GEOS Data Sharing Task Force has not been involved with the creation and use of standards and specifications, but another part of GEOS in which OGC is actively participating is dealing with that, and as Mark will no doubt comment, GEOS is using OGC specifications and standards quite in some depth in terms of its architecture and its standard sharing. So these are some of my thoughts on behalf of the GEOS Data Sharing Task Group. There are obviously complementarities between the work that's going on in GEOS and the work that's being proposed by UN-GGIM. And I'm strongly suggesting that at least the 2 agencies speak to each other. As we've discovered, if 2 agencies are working parallel and don't even bother to interact, the likelihood is that we will not get the value added that we deserve by sharing such information. So I'll stop there and thank you.
Thank you, Fraser. And Fraser's correct. The OGC, working on behalf of the GEO organization, we're a participating organization, and working on a particular architecture committee of GEOS, is facilitating a series of pilots to help not only to resolve the architecture that we're all trying to achieve, the common architecture and infrastructure, but to actually do this in the context of the societal issues. So if you're interested in that, visit the OGC website and click on programs. You'll find background information on the pilots. It is an excellent program, and what's nice about it, it's fully documented. And I'm really happy to say that all of our speakers today, you can go to their resources and find a great deal of documentation and basis on the work that they've done to date. We have one more speaker, and we're right on schedule. What I'd like to do is ask Arnold Crystal to join us on the podium. He's going to be speaking about open source, and I couldn't think of a better topic to close out our day with than looking at the different ways that the industry provides technology, tools, and services to the community. So Arnold, if you have the floor, and the clock is just about ready to start ticking.
I just set it up ticking here, so watch out, I have a camera, so I will take pictures if you fall asleep. Let's see whether I get this managed here.
Is there a question for Fraser while we're waiting for the... There are still pens to be had. Olaf.
We have discussed data sharing a lot this week. We have discussed data sharing a lot this week, so I have a very simple, no very difficult question. To what extent can we use this in the realm of GGIM, or where are the problems, in very short, in case there are, to use it, I mean, reuse your data sharing principles?
The answer is, I think we can use the principles and the implementation, because although it's been developed for a different type of data set, it's still geospatial data, and rather than reinventing the wheel and starting all over again and looking at these things from scratch, we should build on what is there, modify and improve it if necessary, but certainly a substantive amount of information and work has been done on which we can build the UN-GGIM.
Excellent. Let's get the microphone over to you.
My question comes back to the privacy studies and the liability studies and the legal studies that you talked about. One of the concerns that I have dealing in an open data environment which tries to fuse non-spatial data with geodata is that I'm not quite sure how far some of the privacy and the liability studies have gone. International law and in the Canadian context with the U.S. Customs and the Continental and North American Free Trade Agreement, I think this is all undiscovered country just yet. And as we move towards more free trade zones, this area of activity is more and more an economic activity, as well as the traditional world of surveying, mapping, and geospatial analysis. How far has the OGC gone in this context, and what are the plans for the future in terms of undiscovered country?
I can't answer on behalf of OGC, but I can answer on behalf of GEOS. The answer is a long way. The studies that I mentioned that are being published or released this week are very good. And I've read all, of course, the Canadian studies, and as you know, my own group is working with the legal group at the University of Ottawa to take these things even further. There are still many unanswered questions. We started off in GEOS with this thought of keeping the lawyers away from GEOS so we'd never get anywhere. But we're now round to the point where we recognize that we have to take very careful cognizance of some of these legal and administrative aspects. Now, the economic aspects are central to what we can and cannot do with GEOS. Underlining everything when a national delegate speaks is the underlying sub-context of what does this mean for my economy and for my business and so on and so forth. We have to accept those realities, and it's much better if we bring them out into the open and deal with them, rather than let the subtext. So for example, all of the issues of why people would not share data, we pulled them out, we looked at them, we exposed them, we discussed them and said, here are these. Do with it what you will. So I think we can build collectively on the work that's been done by GEOS, and I'm very much hoping that UN-GGIM would pay attention to the work that GEOS has done, in its ongoing work. Because if we start all over again, it'll be plus de change, plus de même chose, more talk, no action.
And I guess my sort of bottom line concern, is that what we've heard is the technological and standards piece in comparison. Looking 5 years out, we'll look back and say that those were the easy pieces. And the real tough sledding ahead is the privacy and the interjurisdictional liability questions and the economic questions.
I can only agree, and we have started. We have started the process of, in fact, addressing these as carefully as we can, and at least identifying, one, the things we do know, and two, the things we do not know, and how to address those is the way ahead. The technical stuff is relatively easy. The other stuff is much more difficult.
So from an OGC perspective, as you well know, we have long been working on rights management and other types of techniques in a standards environment where we can begin to address some of these really gnarly issues, particularly when you start bringing different sources together in a web service stream to produce a result. There are issues not only of licensing and ownership, but there could be derivative privacy issues or derivative security issues. There may be a huge amount of uncertainty or accuracy or error induced in that result. And there could be liability on the use of that information. So we're fortunate to have on our board of directors a lawyer who started out as a cartographer and an image analyst, and he now specializes in spatial law and policy.
He's on the data sharing legal task force.
He's on the legal task force, and he's becoming very well known in communities that haven't begun yet to think properly about these issues. And so while OGC will not attempt to solve or advocate for answers to these issues, we want to make sure that our standards work gives enough flexibility to the decision makers to be able to address all of those issues. So when you look at our technology base, you'll see a standard that we're developing called Uncertain ML, Uncertainty Markup Language. You'll see rights management. So you'll see a lot of activities that are focusing on this issue of spatial law and policy. Tough one. Anyway, that was a really good discussion. Arnold, you're all set up and ready to go?
Yes, I'm ready to go, but I'm not going to talk about open source today.
Well good.
Because I always have. So that's not why it's cool. So, because I always have to talk about open source, because I'm the president of the Open Source Geospatial Foundation. And I will be talking about this in a keynote tomorrow morning at FOSS4G, the free and open source software for Geospatial Korea Edition. And so if you want to know what open source, I advise you to either download my presentations or come to the presentation tomorrow. Why do you always enter HTTP into your browser? What does that mean? Come on. Somebody has to know.
That's a protocol.
It's a protocol. Thank you. Okay. But nobody really knows what it is because in Chrome, you don't even see it anymore. You just enter something and it goes there. I want to look at why this is the case. So we're going to be a lot more technological than the previous things, but I will try to integrate the other aspects that we have seen over the run of the day. So you can always download this, and it's very easy to memorize if you can remember my name, and if you can remember that I do not come from the US, and publications. So you find all the things there. I'm sorry that I'm not in the printed document because I was too late. And Korean efficiency is amazing. They got the latest, what was it, the last presentation yesterday morning, and they still managed to print this paper, so it's my fault. I'm bad. So my bad, it's not in there.
You're that pen bag.
I'm going to keep this one here. Okay, so what am I? I'm Arnold Crystal, a geospatial systems architect, which is a big mouthful. I'm a member of the OGC architecture board. And some of the things I'm talking about today, I'm trying to get into this architecture board, which is an integrating instance within OGC. I am OSGeo president, and I'm an OpenStreetMap advocate. That means I don't really go around with the GPS anymore to collect data, but I talk about OpenStreetMap is a good thing. My alter ego is 7, which is an export. So if you're into Star Trek, you will know what I'm talking about. A short introduction. I'm trying to shed a little light on different hypes, which we have been talking about a lot in OGC. Starting with SDI, SOA, SOAP, ESD, ROA, and RESTful. All of these are hypes, and I want to explain why they are hypes and what we can do with them. Then an architecture model, which is the RMODP, the components of the ROA, the Internet and the web. That's the thing where I explain what HTTP really does to us. Some RESTful, REST-linked open data, and ROA, and how it all might eventually come together. Why am I talking about this? Because imagine you have data, population statistics, and want to show them in a map. What do you have to do? You get your data in a spreadsheet, in a database, something, whatever, and then you go ETL, that's extract, transform, and load the geospatial data into your own system. You process it, and then you present it. So, that's okay. We do this every day, and we have been doing this for the past 30, 40 years. And then the spatial data changes. What do you need to do? Well, go back again and do the same thing again. So that's not nice. So a few years back, we started to say, well, we don't need to download it, but instead we can use a service. And we don't need to transform it into our system, but we can actually interoperate because we are sticking to standards. And this is good, but it does not really work well yet. And we'll look into why. So next thing we do is imagine that every geometry that we just downloaded or got through the service has a URL. And the URL is this thing with the HTTP. It means it's a universal resource locator. It is an address in the web, in the internet. Now imagine every geospatial thing has a URL, and you simply link your data to it. So this Excel table you had before, you just also put it on the web and make a link between the two. And then you're done. Because if anything changes, you're automatically notified. Sounds like Alice in Wonderland? Maybe. Let's see how this really works. So to understand this, we first go back a bit in history and look at geospatial data infrastructures, which we have heard a lot about today, spatial data infrastructures. The core idea goes back to the 90s of the last millennium, and there was no ubiquitous internet yet. This is important. Internet was new. It was an infrastructure which came out of universities and was slowly becoming more commonplace, but it's not like in Korea, where internet is everywhere. Even in Germany, we don't have that much internet. It's really great here. I love it. So at that time, we called this a paradigm change from desktop to client-server architectures. And we were really proud because there was the PC, and we worked on the PC, and suddenly we felt, oh no, now we have to separate this and make something new. But in reality, this was called mainframe and was before the PC. And now we call it cloud, and it's again the same thing. So we're always doing the same thing. We get it together, and then we pull it apart, and then we get it together, and we pull it apart, and we continue doing this. So then, during this geospatial data infrastructure thing came another hype, which was called the service-oriented architecture, the SOA. It's a fairly loose concept, lots of room for interpretation. It's software-centric, and this is really important. And it has a single point of access. It's one single URL. You already have a URL there, so you can access, but it's only one single point. You don't have access to each single object through a URL, but only one, and then you have to search in this little hole. You have to go to the hole, you get all the cadastral base map area through this one little hole, out into the internet. And in this time we also developed OGC standards, WMS, WFS, and they appeared in a time that was really interesting, because there was no internet, there was no service-oriented architecture concept, but still the OGC created this standard, which implemented all of these before its time. So I think this shows that the OGC was very up-to-date even in those days. Okay, more hypes. Enterprise Service Bus. Who knows what an Enterprise Service Bus is? It's this thing which gets us from KINTEX to COAX and back twice a day. Well, actually, it's a buzzword. It's being used by big industry to sell you important things. And there's many proprietary and closed source solutions. And now you see I'm an open source guy. And there's high potential for vendor lock-in. Do you know what vendor lock-in is? Okay, I see some people nodding there. So if you buy one of these things, you're sure going to buy the next version of the software from the same guy. And this is vendor lock-in if you cannot choose where to go. So it came to some fame in the geospatial domain because of early Inspire. Inspire started 10 years ago, 15 years ago, 20 years ago. What do you think? 10 years. 10 years ago.
But it was only a name.
Exactly. Yeah, it was a name and didn't mean anything, but it perpetuated itself in all the guidelines. So what we ended up is something like this: an enterprise service bus, and you see it up there, and then the GeoRM layer, and then the different services and the different data stores. We changed this, and now it looks more like this. You have, instead of internet in this enterprise service bus, it says internet, TCP/IP, because this is the network that we're actually using. It's a network. And then you have down there, I cut them off because they come later. We have the same thing, databases and all this information. And now is the question, where does Inspire belong? Is Inspire in the top layer, or is it in between, or is it at the bottom? We will find out later. So, more hypes. Just a similarity of name with SOA was SOAP. It was initially the Simple Object Access Protocol. But then people said it's not simple, so we'd better just call it SOAP. It's like slippery slope. And the basics is remote procedure call and messaging. It's message oriented. You have a message and you send this message to and fro. You can do great things with it. But it requires a client description, WSDL, and is again technology and service centric. I am a software developer, so I understand this. But most people who want to use geospatial data are not software developers, so they don't understand. So we have to deal with this. And it's a W3C standard, but there are many of them, and some of them are dying out. I never said this. There's more hypes. Now, it's RESTful. The core idea is that everything is representation of a resource. Everything is a representation of a resource. Okay, let's see. It's data and not technology-centric. It's a different approach. You don't think in, I have to buy this software, and then this software, and then this software, and then configure it, and then I get out my data. You think different. You think in data. The data is the important thing. And when you have figured out how you want to design your data, and which parts of the data are privacy related, and which parts of the data are security related, then you take the right software and wrap it around the data to provide it in the right way. It's just a different approach to the same thing. And we as software developers have a hard time to understand this. So for me, it took 2 years, 3 years to understand that software is irrelevant. Software is just a tool. Software comes and goes. What is important is your data. That is what has value. It's web-centric, and it implements HTTP correctly. While SOAP uses HTTP as a way to transport things to and fro, HTTP is not a transportation protocol. It's an application protocol. And this RESTful thing uses the application protocol in the right way. It's no official encoded standard yet, but increasing usage all the same. And we have a recent REST committee on OGC trying to find out how we can actually use this to implement it with our own standards. And it is scalable. That means we can simply blow it up if there's more requests for the data. IT architectures. Oh, I forgot to start my watch. I started now, so I have 25 minutes more. IT architectures, RMODP, another one of those acronyms. What does it mean? It's the reference model for open distributed computing. It's the model to describe software architectures, and it was developed in the mid-90s by the DoD. Do you know what the DoD is? Department of Defense of the US, obviously. It's an ISO standard and it's applicable in enterprise systems. Big. So the separation is so-called viewpoints. So we use this way to look at an architecture from different viewpoints. And it starts with an enterprise viewpoint. That's the organizational level. What do we want to do? Why do we want to do it? And this kind of thing. There is a business viewpoint, which is the processes and workflows. There's an information viewpoint. That's data, schema, and the ROA. There's a computational viewpoint, which is services and the SOA. And there's a technology viewpoint. That's technology, software, SOAP, RESTful, APIs, and so on. So you can see there is a goal from people to technology. And in the middle is the data, because data is the important thing. Now, if we look at it from the basics of the ROA, and we apply this to this RMODP perspective, we try to go through a few points. The resource-oriented architecture is an information model. It's not a technology model. It's an information model. It is not a distinct technology, but it uses web technology. That means HTTP and URLs. And they are currently the best fit. Maybe in 10 years, in 20 years, in Korea, somebody invents a new protocol which is much better. But right now, we have the URL and we have HTTP, and it works. So we better use it. The ROA describes condition in which the web works optimally. What's the next basics? We have 3 of them. All data is designed in resources. We had this before. Okay, we have to think data is a resource. And this data can be delivered in different ways. Each delivery is simply a different representation of the same resource. So imagine you have the resource, geospatial data, population statistics, or postal codes. One representation of this postal code is a map. That's what we understand if we are cartographers. Another representation of this postal code could be the square meters. It's a list of numbers. It's the same data, but it's different ways of looking at them. So this is what the ROA does. It takes your data and allows you to look at the data from different perspectives. And the representation is the form of the content in which it is being displayed. Did this just move? It wasn't me. Oh, it was me. I need something to play around with. I take something else. So the separation of form and content is crucial. It's really important. This is even important in day-to-day communication. If you shout at somebody, "I love you," is he going to believe this? Probably not. So the form and the content is something that is different. And it's important that you have both under control, you know what you're doing. And we have heard of this before in HTML and CSS. If you write HTML, it's just the data. If you want to make it look nice, you take CSS, cascading style sheets. So the same thing we do more or less with data. Okay, the third basics of the ROA, looking at geospatial data as a resource, it can come in a variety of representations. And now we go back to the OGC standards, because they work perfectly well. A map image is an OGC WMS, or a tile which is static in the format PNG. Another representation of the same map is the capabilities document. It comes in XML. It's an XML file with metadata. The metadata of the service is also a representation of the service. So it's the same thing. So we should be able to access it through a URL. Very simple. Metadata can also be an ISO profile. I still have some spelling errors there. The profile is the German version. So it can come as an HTML file, XML file, whatever. It's different options. And the coordinates of the geospatial data, they can come in GML, KML, WKT, shapefile, and so on. There's different options how you can get the geospatial data coordinates if you want them. And you can also get a legend, which comes as an image. So if you want to see the legend of a map, you just ask for the legend as an image and you get back an image, and so on. So this will be a map image, and if you click down here, that is the link. I was told to click here. Is this right? Yeah? Okay. I'm learning Korean really quick. Okay, but still, it sometimes doesn't work. It doesn't matter. It's the different OGC parameters. You know all them by heart. Who knows the OGC WMS parameters? Okay, I thought it was more people. I hope this is not too technical. Fraser, please raise your hand. Okay, it doesn't matter. I just continue. It's okay. Ah, there we go. Look at this. So this is the map, and it comes live now from Germany, delivered to us. It's my hometown, and this is the postal code of my hometown. And up here you have these layers, and I want to have a bigger map because you are all very short-sighted. So let's see. We have up here we have the width of how wide should it be. Let's make it 800, and we make it a little higher too. So we say 650. There we go. So this is how you can parameterize a map when it comes out of the WMS. It's very simple. And it's all a URL again. Next thing, the legend. This is just a legend. So you just click on this here down and you get exactly this legend. Yeah, I always have to click twice. Yeah, there you go. This is the legend. It comes from Germany. No customs there, no borders. It just comes flying in. And the OGC capabilities document, I'm going to spare this one. It's all the pointed brackets. It doesn't look nice. But machines understand it. That's good. So far we have seen things that people understand, and this machines can understand it. So machines also use HTTP to communicate with each other. And you can get Inspire. There we have the Inspire banana again. It's not a banana. Sometimes. It's a pineapple. Sometimes it reminds me of a banana. I don't know why. So there we go. So this is now real metadata. You see it's Inspire. It takes a long time to produce, but. And here you have contact information, the properties, the terms of use. You have quality. This one's 100% available, but it's yellow, so it means something has changed in this service. So I should re-upload it. And you have different interfaces with the capabilities document and even the validation for Inspire. So again, this is just a link. HTTP Wonderland, Alice in Wonderland. And the raw geospatial data, yes, this is what we all want. But where does it come from? It also comes from HTTP. So the postal codes of Germany, you get them on my website. You can download them and do whatever you want with them. Or you can ask for them through a WMS as a website. So all the different information has its own address. You can directly address this information. Any geospatial data. Okay, now let's go to the internet. What is the internet? The internet is a domain name system. Have you ever registered a domain? Open source geospatial foundation is osgeo.org. I have to pay somebody, and every year I have to renew this, so I know that this name is resolved into an IP address. This IP address identifies the server in the Internet Protocol Suite, which runs through TCP/IP and TLS if it's to be secure, and uses HTTP. And all of this is called a URL. And I add this human error there because if the internet breaks, it's usually somebody who mislaid a URL or forgot to pay the domain name service system. So on one side we have a hierarchy. The TCP/IP stack is a hierarchy. It is a website with an IP address. And the other aspect is a URL. So a domain name system, what does this mean? DE is the country code for Germany, TUM is the Technical University of Munich, BV is Bauingenieur und Vermessungswesen, subdomain Rundertisch-GCV is RTG, and www is something we don't need. It's superfluous. It's from the 90s. And index.php is the document. In this case, it's not really the document, but it's just a script which will create the document that you get back. And it needs some more ugly parameters like options, content, task, view, ID, tab, and so on. But as a link, if you click on it, it will still render exactly this information. Okay, this is a new website, so again there and there. Okay, there you go. So this is the University of Munich in Germany, and they're still sleeping, I think, so they're a little slow. But here goes, there is the website. And this is the document, this is the web document. Wait, I translate this for you so you can read this. Oh, I clicked on the wrong button. My Korean is so good. But what does this mean? This means this is the hierarchical information that identifies a website. This is one part of the internet, that's the technology. Now the other part is the websites. And they can have different URL for the same document. The flexibility of the domain name system, the private website of my website, can be reached through all of these, and probably more. So that's arnulf.us, www, the main page, Ronald.kris is the redirect to the main page here. Biply is a URL resolver, which will also point to my website. Zspatial is an old domain I still have, it also points to my website. You have this is my provider, the internal server of my provider, and you have 2 IP addresses. So all of this is the same web document. So this is chaos. Because if you take, for example, this one down here, the R329160vh.net, this will change. Next year it's different. What will not change is this one up here, if I pay my domain name service registration, and this IP address down here. Because this is what machines often use to communicate with each other. Okay, now what is this HTTP? It's get, put, post, and delete. Oh, there's so much German here. And these are sufficient to read, write, update, and delete. And we know this. This is CRUD. This is create, read, update, and delete. And this is all we ever need to do in IT. We never do anything else. We create something, we update it, we delete it, and sometimes we read it. So HTTP has everything that we need to do processing. But the web is documented, something like this, an HTML page, and has some information, blah, blah, blah. What does it mean, an HTTP URL? It's links. The most important aspect of the web are links. So now we have first looked at the internet, now we look at the web. And a link is a relation between a subject and an object. So for example, I can link from Metaspatial to the Scrum Alliance. And this looks like this. It's an href, there's the address where I go to, and this is the translation for human beings, so we can read this. Is it a coincidence that geospatial data has similar relations? The postal code can have a neighbor of another postal code. A county can contain a town. So again, we have relations between these objects. And these relations can be mapped using HTTP. And when we do all this, we can use it in the resource description framework, which is the format and the standard which implements these directed relations in so-called triples. You always have subject, relation, object. And geospatial data can be transformed into RDF, but this doesn't really help us. More interesting is the association of spatial data with other spatial data, with other data using RDF. And this is what it comes up to, it's the web. The web is links. So we have a problem, the web is unstable, so we have 404, one of the most known messages in the web, but there is a resolution to this. Because if you move something, just put a redirection status code and say where it moved. So whenever you take something out of the web, make sure you have a redirect where you put it. And if everybody does this, and that's the human error that I was pointing to, if everybody does this, the web works perfectly. It only breaks if we don't do this. Okay, let's skip the Web 2.0 concepts. You know all of this. The technology is also known. This is more examples. So KML, XML, again, you can see these are links. All of them are links. And these are standardized formats. This one by the OGC, this by W3C, also W3C, and RDF. So these are standards and standard formats Then in some cases, this one can contain geographic data. This one is a simple syndication. You get updates to this one. And this one is the resource description framework. Now if we look into the Web 2.0, we put Inspire where it belongs, in the basement, because it's old technology, designed 10 years ago. And it works perfectly down here. But nobody wants to use it with applications nowadays on a mobile phone like this one. GML is a little unwieldy on this kind of machine. But there are wrappers, JavaScript APIs, type caches, download services, and reservices that can use this. So what we need to do is we need to wrap up the hardcore technology down there with nice front ends on the top. And this is what HTTP and HTML allows us to do. And this is my example from Denmark. It's GeoOyoRest Denmark. And they have put this exactly into the web. There you go. It's the geoservicen, and let's see, they have a postnummer. And in the postnummer you can look at the Grenze. And if you look at the Grenze, you get the geospatial data in Web 2.0 format. There we go. So this red area here is a JSON object. It's now on this computer, in the main memory of this computer. We just downloaded it. It's not just an image. The image in the background is a classical Google Maps aerial image, but what we have in front, what we can work with, what we can link population data to, what I started out wanting to do, it's all there and can be used right away. Okay, just the 5 stars of Berners-Lee. If you want to check if your data is ready for the web, go through these 5 points. The first is make your stuff available on the web, whatever format, on an open license. Easy, we can all do that. Especially the open license thing, as we have learned today. Then make it available as structured data. Use Microsoft Excel instead of a scan of a table. The third level is use non-proprietary formats, e.g. CSV or KML or WMS instead of Excel. The fourth level is use URIs to identify things so that people can point at your structured data, make the data addressable. And the last one is link your data with other data to create new information. And this is what is going to happen in the next 5 to 10 years. And I think it's very appropriate if you look at your data and at your policy and check whether it goes together with this way of looking at things. In a summary, the web is the operating system. No, the internet is the operating system of the web. It's exactly the other way around. The web is based on HTTP, and the web is one gigantic app. It's the biggest app we have. It's an application. And the API of this web is RESTful. If you are interested in the architecture model, it's the ROA, and geospatial data is important. Software is just an exchangeable tool and comes and goes. Thank you for your patience.
Thanks so much for that overview. This is a little bit of a microcosm of what OGC is trying to do, is to try to stay with and stay ahead of the curve of the market, to make sure that the work that we do is relevant. It is always a difficult challenge, but those of you who have interest, please jump in and join us. It is a lot of fun. And thanks so much, Arnold. Do we have time for one question for someone? One question? Or are you all too hungry to ask questions? Okay, I think we're almost done. I'd like Jinsu, if you could take us to closure, please.
It's all well. Why don't we give a very approach to all the speakers and the moderators. I don't want to just give wrong kind of concluding remarks. Probably you have, I think there is a consensus on the floor, even without mentioning anything. So we will keep continuing to do this kind of seminar workshop, but I'm really frustrated because I didn't mention it, but it will be very, very difficult to gather all the professionals you have met today at just one place at one time period. It's almost not possible. I mean, we have 2 presidents and three presidents actually. I really, I strongly believe you enjoy the 3 intensive hour workshop sessions. And I just have just few announcements. As I promised, you are all invited. So just go to the room 307. There will be about hour and a half banquet available. So that means a lot of food. So you can assume. And those of you who have to return to COEX, there will be a bus 8:30 out there.
6:30.
It
will be an earlier bus also.
Oh, really? What time is it?
6.
No,
So 9, I believe 9.
9? Yeah, but anyway, as long as you stay in the banquet area, the bus won't go. So we will make another announcement. And the final, my request for the moderators and speakers, if you haven't made copy of your identification, please stop by the outside desk. That's for just administrative things, so please. Did I miss anything?
Yeah.
Thank you very much. Yeah, there is another.
Yeah, I have one question and I have something. So my question is how we can download the file.
Oh, presentation file?
So we can download it from
Chris will have all the presentation available in the website, right?
But
This one.
so not this one, the old file. Which is available from the OGC portal website. So we can upload.
Well, we can upload in an OGC forum or OGC public forum.
And the second thing is, I would like to thank to all the staff of
Oh, yes.
MLTM and the guys on the street.
Yeah. Thank you very much. Let's go for the banquet.
You know that when categorically started with www, it was actually address to something that he first called the internet mesh. But then he thought about an acronym and he wouldn't think that when it was Tim in front of everything must have worked. Yeah, I think I will. Well, today, but I'm going back to the hotel.
Maybe we see you on Saturday.
I haven't bought anything. I'm buying tomorrow.